Okay, moving on with the program. We're here to present SAFE. SAFE has been announced. It's in the news. You can see all the press out there. So this is the second presentation, I believe. We're doing it. Okay. So this, you know me, Amber Huffman, and Bryan Kelly. We're going to split the presentation. I'm just going to talk about the opening, emerging requirements, and kind of the problem as we saw it arise. Bryan will deliver the meat of the presentation, you know, the nature of the solution, and Amber will close with the, you know, early wins and call to action. So not news, right? Top-down regulatory environment has changed significantly for the better, but it involves significant effort. Both U.S. government as well as European Union government have had very specific, articulate, and deliberate actions pushing liability and responsibility of the integrity of the software supply chain to suppliers and hyperscalers, right? So think of it, it's reductive and somewhat informal, but think of it as a very forceful reaction to the SolarWinds incident, right? Where, you know, they're now beginning to talk about actual liability, actual very concrete liability, if you are selling a product with software that you don't know what it is, right? Or that it has known vulnerabilities or known backdoors. So the problem as we saw it, and the reason why we're working together on this is the consumer, in this case, a hyperscalers, in the particular case of us here, it's kind of stuck in the middle, right? You have producers, they do their artifacts, they do their work, et cetera, they produce immutable hardware, but they also produce changing firmware. And then you have the auditors on the other side that want to know that the service is complying. So each individual consumer is doing the same work over and over again, and kind of defining the rules of the engagement over and over again for each individual relationship and each individual incident or experience or episode. So this is obviously very inefficient, right? So we kind of sought to get together and work together on how to solve that inefficiency while at the same time addressing or matching the regulatory environment. So very simple introduction, handing off to Bryan.
Yep. Thank you. So challenges with that previous model that like Andreas talked about, where the hyperscaler would receive the firmware and source code from the device manufacturer, and then go and either use in-house security experts or outsource to third-party security firms to go do that security review. Created this kind of man-in-the-middle flow that just didn't really make sense. Caused the security reviews to take a long time. Manufacturers, like device manufacturers, would come and want to see volume ramp, want to see their products deployed in production, but then we'd have to do these security reviews out ahead of it. Then when they deploy that device, maybe 6 months later, they have a new firmware release that they want to get deployed. Again, we can't deploy it because it hasn't been security reviewed. So we're back through that long process of being a man in the middle between the device manufacturer and a security reviewer. And even if I'd reviewed a device in Microsoft, if Google or another CSP was buying that same device, they'd have to go do the same audit because everything was NDA'd, and there's no sharing of the audit results between them. So what happened is, vulnerabilities would be found late in the production cycle. So as devices get onboarded, typically they'll go through a series of tests, to integration tests. They'll get integrated. Security reviews will be running. Something will be found in the security review. It gets kicked back out, and we start that cycle again. And it just meant that the time to market, and for manufacturers, for them to realize the TAM in a short period of time, this added long delays. Every time it got kicked back out, it went back in through test. It'd come through test, and then we'd find security vulnerabilities from a security audit, and then it's all the way back into test. So it was just this revolving queue that took a long time to get devices through production. As I mentioned earlier, the results would then be, once it's passed the security audits, it's been tested, it's been validated, it's good to go in production. Of course, if that supplier was then trying to sell to another CSP, they'd be stuck in the same flow. And they ended up having like multiple security audits that were, a lot of it was redundant in that process. So we took a step back, and through OCP, we've been collaborating with Google and others, and we discussed what it would take to have secure components. What are the key ingredients in secure components? And it's all the requirements, the security requirements that we talk about in a security call, and then how do we ensure that those are implemented correctly. So for secure devices, I'd say these are kind of the things that we look for. So I'll start from the bottom. But the root of trust, heard a lot about Calyptra today. But a root of trust, a measurement, gives you a quote, tells you what exactly the device is running. Those measurements are a very concise representation of the security posture for the device. So we know that a device can tell us reliably what firmware that it's running. We get SBOMs and reference integrity manifests from manufacturers that tell us what those measurements actually are, and how to deconstruct those measurements and what they mean. But then when we get down to the actual measurements, we're like, well, how do we know that they're secure? How do we know it's implemented as claimed in the integrity manifest and the SBOMs? And that's where the security assessment comes in. So these are the key ingredients, I'd say, to a secure supply chain. Of course, there's a lot, we can get into finer details a lot more. These are like the high level 4 bullets that we'd say is essential for a secure supply chain. So the new model that we're doing underneath OCP SAFE is to get the CSP or the consumer out from being the man in the middle and establishing that audit relationship between the producer and the auditor. And then through OCP, it's facilitating this framework, those results, once the manufacturer authorizes the publication of this, what we call a short form audit receipt, that goes into OCP and can then be distributed out to the various consumers, not just hyperscalers, but all device consumers. An important thing to note about this, it doesn't quite reflect it here on this page, but it's not like the manufacturer produces goods, thinks they're good to go, goes to one of the auditors, fills out the checklists, and then it's published kind of automatically. There is a back and forth. There's never been I'd say a one-time clean audit that comes through. So there's generally a lot of back and forth between the manufacturer and the audit as they go through, fix bugs, and work to get that clean assessment that they can then publish. So a little bit about the framework here. It is a systematic appraisal. So I'll talk through this diagram on how the flow works. So there are checklists that get published out in OCP. You're already going to see on the website under the security tab. All of those checklists are out there. For the SRP criteria for the security review providers, there's criteria for those. There's criteria for devices and device vendors that are manufacturing devices to look at that criteria for code. They select an SRP to do the security audit and the security review when the device is ready or when their update for that device is ready. They send it in. They get the checklists off of OCP. They look at it. They work with the SRP to get the security audit. When that audit comes back clean, they'll talk with the SRP about publishing that audit through OCP. And it's not a full audit. We call it a concise audit. So there's a concise short form audit that gets published. That's really a receipt to say that the audit was performed, and any call outs of vulnerabilities that remain will be in that short form audit. A lot of people ask about, hey, what's the relationship between this and common criteria, or this and FIPS? There isn't actually a relationship between them. This is, we're not trying to get, we know devices are all different. We're not trying to get them to fit into a certain profile. We know not all devices fit into a nice square box or, so this is specific to OCP security requirements around code integrity running on the device, security implementation, secure boot implemented correctly. We talked a little bit earlier, or the talk just before us was talking about Rust. Make sure there's no vulnerabilities in terms of memory safety, and that parameters are all bounds checked. All of these things that would typically happen in a security review. And then, of course, when devices pass that security review, they get an OCP SAFE stamp in the marketplace and are listed on the marketplace. And this removes the duplicate audits that were happening previously, and it also helps with the time to market and realization of TAM as it happens during the development process and normally during the device lifecycle without CSPs in between going back and forth. That's over to Amber, right? On this side? Oh, this is still me? Okay. So the programs under OCP, a little bit about the security review providers. We have some 3 that are on board for program launch, and they've really been instrumental in helping to set this up in terms of helping with how we would qualify security review providers going forward. It's not like an old boys club of exclusive security review providers. Others can become security review providers. There's criteria that has to be met to be a security review provider. There's 3 in the list. Also, some manufacturers have already gone through OCP SAFE. I think in an earlier talk, Andreas mentioned that we have Calyptra has gone through. We also have some other wins that Amber will talk about shortly.
Thanks, Bryan and Andres. So just to wrap up, so we have a lot of industry perspectives on OCP SAFE. If you check out the blog that OCP published, it includes perspectives from the 3 initial security review providers that have already been through the program to join as security review providers, Atretus, IOActive, and NCC Group. On the device vendor side, we're very pleased of AMD with a GPU product has gone through the effort, SK Hynix with an SSD product, and then Intel has a demo of an end-to-end attestation that you can see in the Expo Center. So great response, and we're only getting started. And just really pleased with the partnership with Microsoft and Google and OCP to get it in place. We definitely need your feedback and how we can evolve and make sure that this is a flexible framework and serves the entire community as we move forward and really raises the bar for assurance. So in terms of call to action, there are a lot of artifacts out there. So if you go to visit the OCP SAFE project page, that is housed underneath the security project. There's the GitHub that has a lot of the materials in terms of the SRP checklist, what a device needs to provide in order to go through the program, all of those good things. You can check out the marketplace. There is an OCP SAFE badge. If you take a look just back at this page, there's an example on the lower right of here's the SK Hynix product with the OCP SAFE badge and verified by IOActive. So you can see those types of examples. And so then if you have questions, so Steve Helvey has been fantastic at the OCP Foundation of getting this in place. Bryan and Andres and many others like Eric and many others have been helpful at getting this going. And so we're really happy to bring this forward as a community. And if you really want to support us, get your OCP SAFE t-shirt, so they're in the back. And Andres has a t-shirt, but it's not on, but we'll forgive him. So with that, we'll take any questions you have.
Quick question about reproducible build. So going from source to binary is always an issue. Is it something you look into, or do you expect everybody in the review or marketplace consumer will actually use the source code and then build themselves?
I can take it. Yeah, that's a really great question. So Going from the source to build, that's one of the things that the reviewers will actually do is build and compile and verify that measurement. And then the reference integrity manifest that I mentioned earlier has that translation from device quoted measurements, because the measurements you get back from the device, the root of trust will give you, will look different to the binary in your hand or on disk. So that has a translation in there, and that's also part of the audit criteria.
Thank you.
He gets a T-shirt, so yeah. Anybody asks a question, they get one of these T-shirts. Yeah, it's how you win one.
So my question is, at what stage in the life cycle do you come to SAFE? For both of you who know me, I'm from ARM, right? We provide IP, we don't build silicon. So what's our role in getting SAFE approval for our products, and how do our customers come to you?
It's a complicated question because it kind of goes to the business model. It's a reference code, it's an IP block. What is the actual thing, right? So if you look at, there's an SSD, there's a GPU, there's a block that is meant to be the final product, right? So I think at that stage is the one. One thing to highlight is, firmware changes over time. So those are points to revisit OCP SAFE.
And I can add to that, for ARM and those kind of models, if you look at what's happened with Calyptra, Calyptra is an open source project, so it's fully transparent, silicon, firmware, or tools to validate it, everything. That's gone through OCP SAFE. If something's, and people that are building on that then, they have that reference that's gone through SAFE. So any delta from that, they're going to get evaluated. But if it remains consistent with those measurements, then they get that SAFE report.
One last thing to add there. Typically, an IP block is not something that would show up on the OCP marketplace, but we can work with Steve and the OCP team to make sure we figure out a way that for IP blocks, references, implementations, where is the place that you can find out about those as well.
I don't know if it was mentioned earlier, but the Intel demo over there also encompasses SBOM. Can you guys get into a little bit about essentially how SBOM comes into play here?
Yeah, I can talk a little bit about SBOM. So the software bill of materials is now one of the federal requirements to ship with software and services. So we do include that in the package. And that helps with the reference integrity manifest. The reference integrity manifest is very narrow, and the SBOM is a little bit more inclusive of the packaged goods and all of the other bits and pieces that might accompany the device. So you may have a device that's quoting firmware. It also has a driver. What's the total package and all of the components that come together. So that's the relationship. He's got to get his T-shirt. Yeah.
Thanks for putting this together. I'm a little bit confused about when the vendor provides their code, the RIM, and the software bill of materials. Is the code required to be open source, or can it be NDA'd when it goes to the security review provider? Do I get to look at my competitor's code?
No, I think that's I think that's kind of part of one of the appeals of building this structure with a central broker like OCP, which is neutral by construction. I think a lot of people would have some reservations in giving source code to Google if they consider Google is a competitor. So we really didn't want that perception to be an impediment to the security of our products. So go give your code to IOActive or NCC or whatever. Don't give it to us. We get the form and the audit from the marketplace.
There's the usual. There will be the normal NDAs and liabilities.
Normal NDAs,
and
yes.
First sons and the usual thing.
Yes.
Thanks.
So one of the things that I didn't hear you speak to is essentially the mutual recognition agreement between the cloud service providers. I mean, the benefit that's supposed to exist for the vendors is they one and done. But that assumes that all of the cloud, all the customers are basically going to accept that, and they're not going to pursue others. And you didn't really sort of talk to that, because that is actually sort of a core element for this to work.
Wait, that's a great question, right?
I probably glossed over it.
Huh?
I probably glossed over it as we were.
Yeah, it was glossed over.
Yeah, but I think, well, I mean, we all want to take the answer.
Yeah. You take it. Ron.
Well, if you look at the SSD specification at OCP, right, NVMe OCP specification, right, it has a very well-defined and comprehensive security section to it. It's co-authored by Google and Microsoft, right? So that's sort of an example of how we want this ecosystem to work. I think you want to take that.
I mean, as you look at it as well, there is like, if we take that OCP Datacenter NVMe SSD example, you have where that is comprehending probably 95% that's common amongst the people that are providing that. But there's still going to be some slight differences of vendors, a customer-specific feature or whatnot. So I would envision that you have that certificate and that audit that covers the 95%. Now, does there need to be a little bit additional work for the specific features for a particular customer? There may be, but we're hoping that it is not a full new audit is what I would throw out there. But
Yeah, no, that's accurate.
In fact, Google's only additional requirement to the NVMe thing is the barcode format, which I don't think NCC will have an opinion on that. But yeah, just to point an example. Thanks, everybody. Thank you.